So we just learned all about how to find percentages in StatCrunch after finding the z-scores, and we even learned how to cheat a little bit and not even have to find a z-score. Now we want to look at what happens when we want to find a percent between two values. So let's go back to the example that we were just looking at, and that example said that we have a normal model for SAT scores of 500, 100, and we're looking for the percentage of scores between 450 and 600. And again, if I were dealing with the empirical rule, it's easy to say between two scores as long as they're exact amounts in terms of exactly one standard deviation in one direction or the other, or two standard deviations. But we want to be precise because, again, the empirical rule is just an estimation. So the first thing I would do is draw a picture. And my picture shows me roughly the size or shape of the area that I'm trying to find the probability of. Then I'm going to find the z-scores, and I actually, in this case, have two z-scores to find. So I need to find a z-score for 450, which would be the 450 minus 500 over 100, and then I need to find one for 600. So that is what I've done here. Again, notice my observed values came first, the 400 and the 600, minus 500 divided by 100, and I get my two z-scores. Then what I'm going to do is I'm going to go to Stat, Calculated Normal, and Between. So I had to fit this right over here. So notice what I did is on the last video we went to Stat Calculator's Normal. This time I clicked the Between button. So Between gave me essentially two places to input my data, and I put negative 1.5 first because we always go left to right because, again, we're looking at a number line. So negative 0.5 and 1, and this is just saying that x is between those two values, and that's what we want. And then notice it gives me my probability. So my probability that x, or z in this case, is between negative 0.5 and 1 is 0.5328. How would I talk about that in context? That the normal model estimates that 53.28% of scores on the SAT fall between 450 and 600. Now, just as I did before, I really want to make sure that I did everything right. And so even though in many questions I will be asked to find the z-score, maybe I'm doing this question in my stat lab and I don't have to find a z-score, or maybe I just want to check my work. So I'm going to go back to Stat, Calculators, and Normal, just as I have been doing for all of my questions. And in this case, we were looking at, again, a between function. And my mean was 500 and my standard deviation was 100. And instead of putting my z-scores in here, I'm going to put 450 and 600 and click compute. And as you can see, my probability, or p-value, of 0.5328 matches what I found when I found the z-scores. As always, I like to throw in a little bit of practice for you to do. In this one, I'm telling you, hey, don't show me any work, which I don't normally say, but this is a really good practice for StatCrunch of how you can do questions like this in my stat lab if they don't ask you to find a z-score and just ask for probability. So press pause, try all three questions, and then press play to check your work. So notice here, it gives me a normal model and it tells me that the mean is 24 and the standard deviation is 6. And so if I'm going to do this in StatCrunch, then 15 is the number that I'm going to put where it says P is probability that X is whatever. I'm going to choose less than or equal to 15. And so let's take a look at what the screenshot looks like. Again, here I'm using 24. Here I'm using 6, and that came from the mean and the standard deviation. I had to change them because I wasn't using a z-score. And so now I found the probability that x is less than 15 is 0.0668. The next one I apologize, I clicked a little bit fast on that one. The next one, what percent of cars get between 20 and 30? So here, again, I'm going to keep the 24 and keep the 6, but you can't see up here there was that between button that I clicked. I clicked on it and that allowed me 2 spaces instead of just the 1. And notice I just entered 20 and 30 and found the probability is 5.889 essentially if I round it. And the last question says more than 40. And again, without having to find a z-score, I'm going to keep the 24 and the 6 right where they were. I'm going to replace my value here with 40 and make sure this is greater than because it's more than 40. And I end up with 0.0038. Now keep in mind that if you had to do this, say for an assessment, and your instructor, myself, asked you to find a z-score, then find the probability, then here I would be taking my observed value minus my expected value of 24 and divide it by 6, and that would give me negative 9 over 6, which is negative 1.5. Plugging that in over here, I would use mean of 0, standard deviation of 1. This would be negative 1.5, and then I would find my solution from there.